Hey, what's up, YouTube fans? So what I wanted to make a YouTube video about, right, is how most of the evolution of the human body took place long before humans, right? It took place in non-human creatures, only later humans evolving. The vast majority of the evolution of the body that we now have took place long before our ancestors were human, right? Which connects to something that I made a video about like a month or two ago, right? Where I was talking about how, one of the fallacies of irreducible complexity, right? Irreducible complexity arguments is that people will think that, if something is needed for human survival or reproduction, that, that proves that our ancestors had to have always had it from the beginning, right? So like, since humans can't survive without a brain or without a heart or without without lungs, and we can't reproduce without our reproductive organs, so therefore that proves that our ancestors must have always had it from the beginning, because how did they ever get by without those things, right? But what I explained on another video, right, is that it really doesn't matter if humans need those things for survival or reproduction, so long as we can show that there are other living things that can survive and reproduce without those things, and that humans could have evolved from creatures with a body more like those things, right? Then it really doesn't matter if it's necessary for human survival and reproduction now, right? Because the evolution of these features took place long before our ancestors were human, right? And so back when our ancestors didn't have those things, they had a differing body setup where they didn't need those things. Then only long after they evolved those features, those organs, did they eventually evolve into humans, right? But so in any event, the topic for this video, right, is talking about how really most of the evolution, the vast majority of the evolution of our body took place long before our ancestors were ever human, right? Which further is evidence towards the point of that, it really doesn't matter if something is needed in humans, right? Because it was long before humans when these were evolved. So to understand this, we need to understand phylogeny, to take into context phylogeny. So phylogeny is where we study, how closely related are differing species, right? So, in the case of humans, our closest living relatives are chimpanzees and bonobos, right? And in the case of chimpanzees and bonobos, for every biological system of the body, it's nearly identical in them compared to us, right? Broadly speaking, it's nearly identical. I'm not just saying that. I mean, my videos, I've done differing videos on the reducibility of differing biological systems of the human body is mostly the same in chimpanzees and bonobos, nearly identical, right? And so even though it is true that for most of these biological systems of the human body that they're trying to say that it won't work unless you have all the parts together at once, we can actually show other living things which have some but not all of the parts that humans have, and it still works just fine. But even though that's true, what's also true is that in chimpanzees and bonobos, for every biological system, they mostly do have all of the parts together at once that we have, right? So, whether it be the respiratory system, circulatory system, musculoskeletal system, nervous system, digestive system, integumentary system, it's all nearly identical in chimpanzees and bonobos, right? And so, the main systems that the ones where there would be the biggest differences, right, are the nervous system and the musculoskeletal system. Now, in the case of the nervous system, for every part aside from the brain, it's mostly the same, right? The brain is the main part that's different. And even in the case of the brain, they still have the same fundamental brain structure as us. The difference is mainly that certain parts of our brain are much bigger, right? Which is why we're more intelligent than they are, right? But aside from that, the nervous system is mostly the same in chimpanzees and bonobos, right? And in the case of the musculoskeletal system, that's another part that is one of the biological systems that underwent the most change since our last common ancestor with chimpanzees and bonobos. But even in the case of the musculoskeletal system, broadly speaking, is mostly identical to theirs. It's mostly all the same parts. Most of the differences are just modifications of already existing parts, not whole new parts, just tweaking of already existing parts that they also have, but it's just different in us, right? But it's the same part, right? So like there's differences of our rib cage, for example, but they still have a rib cage, right? Which is still mostly structured the same as ours, right? Or same for the feet, right? The feet are obviously part of the musculoskeletal system that's very different in us, but it still is the same fundamental structure. They still even have the same phalangeal formula of their feet, 2, 3, 3, 3, 3. So it's really just tweaking an already existing structure for the most part, it's mostly, broadly speaking, not much totally new traits, just modifications of already existing traits, right? And then also with the musculoskeletal system, we know from fossils of extinct creatures even more closely related to us, which had even more similar musculoskeletal system to us, right? Like Neanderthals, Homo erectus, right? And so that all the more just shows how very little of the musculoskeletal system had to change in our species particular. Not that there wasn't a lot that changed, mind you, but broadly speaking, it's relatively small, the changes that happen when we look at it in the big picture, right? And so, and then even, something that's much more distantly related to us, like a dog, right? A dog is far more distantly related to us than a chimp or bonobo, but still, as placental mammals, they're still much closer related to us than the vast majority of animals. And even in a dog, it's mostly the same it's mostly identical for most biological systems, the circulatory system, the nervous system, respiratory system, even the skeletal system, in a dog we see much more significant differences, but even for them, it's still mostly the same skeletal parts, mostly just differences of modification of already existing parts, right? rather than, like a difference of like, oh, we have this and they don't, or vice versa. There's some of that, but most of the differences are just tweaks of already existing parts, right? And so even though humans apply our bodies towards much greater purposes than a chimp or a bonobo, we build iPhones, we drive cars, we've even been to the moon. We've achieved far greater things than they have. And it wouldn't have been possible without our body, right? Without our arms and without our sensory organs, without our brain, right? But nonetheless, right, it turns out, right, that a body mostly the same as ours is just as much good for a lifestyle that a chimpanzee lives, right? Even though they don't achieve these very grand things that we achieve, right? A body mostly the same as ours, it's just as good for doing the things that they do, right? Arms and hands mostly the same as ours, even though we use them to, build things like iPhones, right? Arms and hands mostly the same as ours, it turns out, are about, just as good for tree climbing, right? And so, most of the evolution of our body, right, took place long before our ancestors were ever human. It was only long later, after most of it was already evolved, that our ancestors eventually evolved into humans, right? Which is why it really doesn't matter if, like, oh, humans can't survive without this, humans can't reproduce without this, because our ancestors were not human back when they didn't have those body parts, and they were far different from humans, right? All right, that's all for now. See you guys.